Okay, so this is what we need to solve. Okay, then this is the question we got, and this is the formula that we get from when you have this component. You can write them in times domain like this, and in S domain like this. Okay, so all the components are there, and this is for the input voltage, the condition that we're going to have. Okay, now when you go to this question that we need to solve, you can see we're working with an input unit ramp. Okay, so this one is going to be a unit ramp as our input. Okay, and we got our resistor, capacitor, and then this is the value for the final equation of V out. Okay, and as you can see, there's no such things as initial condition here, so meaning if we have to get the equation, this is loop 1 and this one is loop 2. So I'm going just to write them here so then you can see if you apply the Kirchhoff law. Okay, so for this one we know that the voltage here equal to the sum of the voltage of this resistor and that capacitor. So it's gonna be V in will be equal to VRT plus VCT, and then like the voltage, the input voltage equal to the sum of the voltage across the loop, and on the second loop we don't have any input voltage, only the output voltage, and they are in parallel. So the voltage across the capacitor equal to the voltage across the output. So then we're going to write it in this form: Vc of t equal to V out of t. Okay, once you've done those part, so then we're going to write them in this form. Okay, so what we're going to get, we only have the resistant capacitor. We're gonna keep the voltage from now as it is, so it's gonna be V in of t equal to I t times R plus 1 over C integral 0 of 1 I t dt. And for V out, it's gonna be the same, 1 over C 1 0 it dt equal to V out of t. Okay, and once you get this form, we're going to convert it into S domain. Okay, so we're going to convert this equation, both sides, into S domain, and likely we have no initial condition, so it's gonna be just for straightforward. So we're going to convert them into this form that you see here. So for the capacitor, it's gonna be 1 over CS. For the resistor, it's gonna be R. Okay, so let's go here. So V in on the first loop will be Vs. I, it's gonna be ISR plus 1 over CS IS. Okay, and this side is gonna be similar, CS IS equal to V out S, and then we're going to solve for current from the first loop plus and 1 plus CS. Okay, and our question stated we need to find V out. Okay, now what is V in? So before we get to that, let's get the equation for the current, which is gonna be, we're going to divide both sides by this equation here. So it's gonna give us V in of S R plus 1 CS. Okay, and this side, the way we need to find V out. Okay, and we know this is the equation that we got for V out, equal to 1 over CS I S, and we need to replace the value of I into this equation. Before we get to that, we need to define what is our V in. Our V in, it was said that it's gonna be a unit ramp input. So if the unit ramp input, what's gonna be our input? And as you can see, we got this information here, unit ramp input. That's why we say unit ramp input. You're going to come to this table. Where do we have ramp? This is where we have ramp function, and this is the, in S domain, the answer for a ramp function. Now, what is a unit ramp? When we talk about unit ramp, we're gonna see this one, where A equal to 1. That's what we call unit. So this is the table for the input. So it's gonna be 1 over S square. So as for that, so it's gonna be 1 over S square. Okay, and meaning that our current equation, it's gonna be now 1 over S square R plus 1 CS. Okay, and remember that we need to find V out. Now the equation from V out is gonna be, okay, we're going to replace those two equations. I'm gonna put some space, maybe just say this is equation 2 and this is equation 1. So we're going to put 1 into 2 into 1. So we're going to replace it there. So we're going to get an equation like this: 1 S square R plus 1 CS. We're going to have this is what we're gonna get for V out. Okay, and then we're going to, it's gonna be something like this. And then if you move that the numerator down, then we're going to remain with 1 R plus 1 over CS. Okay, this is what we're gonna get. And if I have to write this equation here, it's gonna be 1 over S square. I'm going to move this part inside, so then I can simplify with this other functions. It's gonna be 1 C R S plus 1. Okay, this is what I'm gonna get here. So, and then everything will be equal to 1 S square CRS plus 1. This is what's gonna be for my equation here for Vout. And once you get this equation, this is the equation for Vout. You have to replace the value that you see here. Okay, R equal to 1 and F equal to 5, and we know that R equal to 1 and C equal to 5. Okay, I'm going to replace this equation, this value here. So we're going to have 1 s squared 5s plus 1. Okay, so this is what we're going to get here. And then once you get this equation, you have the option. So what you need to do, I'm going to stop here. The idea was to show you how you can apply the input ramp function. This is the input ramp function. The goal was to show you how you can apply the voltage input as a ramp function, how you're going to work out. So you know that Vin, you're going to replace Vin with the ramp function. But if you want to go further and get the final answer to this question, you have the option. Once you get to this stage, you need to check okay, you need to check and to see if we can find this into the inverse Laplace table. Inverse Laplace table. If you can find this form. If you don't find this one, then you're gonna go for partial fraction. Okay, you break it down, and then once you find your partial fraction and the unknown, you solve for the unknown, you look for you apply now, which is gonna be very easy for you. You apply now the inverse Laplace. Okay, you're just gonna get the form into the table. Then when you're done with the inverse Laplace, and then you're going to replace t. Okay, so meaning you will get here Vout in times domain, and here you're going to replace the value of t, which is 18 times dot 1. It's gonna be 18.1. Then you should be able to get the answer you see here. What is the answer? 13. Then you're gonna get this answer, 13. Okay, you should be able to get this answer from here. Okay, I'm gonna leave this partial fraction out. I'll show you later on, if I get the chance, how you should go about partial fraction. Okay, so this is what you should do about this question. The goal it was for you to see where you can apply the unit ramp, okay, and where it's going to be needed. And we even use this side. This way you see the unit ramp. Okay, now this is it.